Hello everyone, today we will talk about Ch12.2 polynomials. In this session, you have many things to learn or to memorize. What does that mean? Okay, so pay attention. First of all, we are talking about page 13. So you can have a note and also please study yourself first. And first of all, here's a name called monomials and polynomials. Okay, you can see these two terms are very similar, right? So in Chinese, monomials means 單行式. For polynomials, it means 多行式. So in the meaning, you can see just like one is a singular form and one is a plural form, right? So in short, I can conclude in this way: monomials, that means the expression only has one term, okay, one term only. For polynomials, it may has more than or equal to one term. That means it may one term, two term, three term, four terms, etc. Okay, for this one, just only one term. Okay, so but the books have told you that the terms have some condition. For example, it may be what is a polynomial? What is a monomial? It may be a number, for example 7, -1, 3.2, or a fraction. Okay. Also, it may be just a variable. That is the unknown x, a, b, c, or the one with a index is also a monomial, right? And also, it may be a combine of these two. That is a number and a variable with the positive index, okay, positive integer index, okay. So you can see the combine, that means the multiplication. That means 7 times x squared, okay. Only multiplication is the combine. So maybe 7 over 4 and then a cubed b is also a monomial. So what is not a monomial? That is the number, for example, a fraction here. If the number have a variable, that is the unknowns a, b, c, x, y, z, on the denominator. If the unknowns is in here, that is the lower part of a fraction, then it is not a monomial. So for example, 7ab over -2 c squared. Okay, you can see we have an unknown here on the denominator, so it is not a monomial. Okay, for the others, usually it is a monomial. Okay. So for example, 7a not 7 many times 6 x squared y divided by 5. This one is also a monomial because this one is just a number. It does not contain any variables x, y, z. Okay. So after you can distinguish which is a monomial or which is a term, then we can learn how to count the terms, count the number of terms. We are going to count the number of terms of a polynomial. Okay, for example, I give you an example. For example, 6 times x to the power 3 minus 4x squared plus x minus 11. Okay. Usually, how can we count the number of terms? We usually use the addition or subtraction to distinguish the number of terms. For example, in this expression, you can see we have 1 minus here, 1 plus here, and 1 minus here, right? So you can see we have 4 terms here. Why? The first term is here. The second term is here, -4x squared. The third term is the positive x. The last term is the -11. That means, in fact, it means 6x cubed plus a -x squared plus positive x plus a -11, right? We have this 4 plus here. 3 plus. So that means we have 1 term, 2 term, 3 term, and 4 term. Okay. You can see 4 terms add together. So usually we use this to consider the number of terms. Okay. For example, we do one more example. For example, a squared b minus ab and then plus 7. Okay. Then this one has only 3 terms. First one, second one, and the third one. Okay, consider you may look for this symbol. In fact, we have the plus here. That usually for the first one, we do not write down the positive sign here, right? So the number of terms is easy to understand, right? Then we will talk about another concept. That is, for example, this one, we know that the number of terms. The number of term is equal to 4, right? Then for each terms, that means this one, and this one is a monomial, right? Only one terms. Then we can see usually it is considered of 2 parts. For example, look for this one. For the first term, 6x cubed. Usually we for each term we consider of 2 parts. The first part is this one, the numerical part. We will call it coefficient. Okay, coefficient is equal to 6 this time. So the numerical part, that means the number besides the variable. You can see this time the variable with the index is this term, x to the power 3, right? So besides this term, we have the number in front of him. It is the 6, right? So this one, 6 is the coefficient. Okay. So for another name we'll call is the degree. Degree will be here, right? We have already learned what is the index. So this one, x to the power 3, this one is the index of the variable x, right? So the degree is equal to 3. Okay. Then we look for one more term. For example, negative 4x squared. The second term, negative 4x squared. So we know that the number besides the variable is the negative 4. Okay. Be careful for the negative signs. So this one, coefficient, is negative 4. Then the degree easy, right? Is just 2. Okay. But be careful, some terms may not only has the x to be the variable. For example, the books tell us this example, negative 8 p to the power 3 q squared. Okay, this one. Okay, for this one, you can see the coefficient is this part, negative 8. For the degree, you can see this time we have 2 unknowns here, p and q. First one is power 3. The second one, the degree is 2. So how can we find the degree? The degree here is equal to the sum of the degree. That means 3 and 2, add them together, 3 plus 2. Okay, remember the sum, not multiplication. So p plus 2, not 3 times 2. So it is equal to 5. Okay, just add them together. Okay. So now we can draw the conclusion here. For the number of terms of polynomial, we know that just use the addition or multiplication to spread them down to number of terms. For the coefficient of a term, when we consider unturned coefficient, in fact it means the numerical part. That means here just the number. Okay, not consists of any variable x, y, z. Okay. Then for another terms, that is called the degree of a term, is the sum of the degree, sum of the index, I may say, of all variables. Okay, add them all. That means, for example, this one, 3 plus 2. Okay. Then, so we have learned 2 more terms. That is the coefficient and the degree of a term. Okay. Then, I teach you one more terms that is called the degree of a polynomial. For example, 7a squared b plus 6x minus 4 and then plus 2 y to the power 4. Okay, so we can see the number of terms is 1, 2, 3, 4, right? For the degree of this term, this one, the degree is 2 plus this one, in fact, is b to the power 1, right? So 2 plus 1, so 3. For this one, degree is 1, right? For this one, oh, you can see there is not any x, y, z, just the number -4, right? This one is special. We will call this one constant term. Constant term. That means the term without any x, y, z or abc. We do not have this one. Just the number. For example, 0, -1, or 6. Okay. Then the degree, because it does not have any variable, so degree is 0. Okay. For this one, we know that the degree is just 4. Okay. So for each term, we can count the degree at 3, 1, 0, 4. Then for a degree of a polynomial, we just find the highest one. That is this one, 4. So that means the degree of the polynomial is just the highest degree. The highest one. Okay. Don't add them all. Do not 3 plus 1 plus 0 plus 4. No. Just find the highest one. So this is just 4. Okay. So we have learned how to find the degree of a polynomial. Okay. And also we have told you the constant term, the meaning of the constant term. That is no variable, no x, y, z, a, b, c. Okay. No variable, just the number. Then, this one is constant term. So how can we call the name of this term? We can just call the name using the variable. For example, this one is the variable is just y to the power 4, right? This one is just the power y to the power 4. For this one, no variable, so constant term. For this one, the variable just the x. For the first terms, the variable, we have a squared and also b. So the variable, the term is called a squared b term. Okay, a squared b term. Okay, this one is a squared b term. This one is called the x term. This one is constant term. And then this one is y to the power 4 term. Okay, we should we learn this one for later on. We know how to find the like terms or unlike terms. Okay. So, we have talked about many things. So let's do practice. For example, 6 x squared minus 1 plus 3 over 2 x to the power 3 minus 4 x squared y to the power 3. You can see for this one, we have 1, 2, 3, 4 terms. So the number of terms is equal to 4. Okay. The coefficient of a term, for example, this one, the coefficient of x squared is 6. The degree is 2, right? For degree of the whole polynomial, for example, this one degree 2, this one degree 0, this one is 3, This one is 2 plus 3, so 5. So the degree of polynomial is 5. Okay. For the constant term, which one? Of course, this one, because does not has any variable. So this one is -1. Okay. So this one is practice. So the arrangement of terms, then the descending power or ascending power, I think you can know it by yourself because it's just very easy to understand. I'll talk about the last concept. That is the like terms, page 17. The like terms or unlike terms. So in fact, this one is very important. For example, we have these two terms, 2x squared y plus 7xy minus 2yx plus 3xy squared. Okay, so you can see this time we should count the number of terms. Oh, 1 term, 2 term, 3rd term, 4th term. We have 4 terms. But be careful, for the first term, the term is called the x squared y term. For the second one, it is called the xy term. For the third one is yx term. For the last one is xy squared term. You can see we have 4 terms here, but you can see these 2 terms in fact are the same, because we know that for multiplication, xy in fact is equal to yx, right? But for these two, they are not the same because the square is on different ways. This one, the square is for the y. This one, the square is for the x. So they are different. X squared y is not equal to xy squared, right? So you can see that means these 2 terms are like terms. And these 2 terms are unlike terms. Okay? Of course, these 2 and these 2 are also unlike terms. They are not the same. That means for like terms, the 2 terms must have the same variable, xy, and also the degree is also the same, x1, y1, y1, x1 are all the same. Then this one are the like terms. If any missing, then they are not like terms, they are unlike terms. For example, x squared y and xy squared. Although the unknowns are the same, but the index are not the same, right? So they are not the same. Okay. So to conclude, that means like terms is the terms have same variable with same index. They are totally the same variable, same index. Okay, all are the same. Beside the coefficient. Be careful, beside the coefficient. For example, 7x squared and -4x squared. They are also called x squared, right? Although the coefficient, one is 7, one is -4, but they are like terms. Okay. For the constant term, 7 and -4 itself. These 2 are constant term. So we know that in fact there are no any unknowns here. So these 2 are also like terms. Okay. Later on, I will talk about what is the use of the like terms. In fact, it is about the 12.3. Okay. And then I will talk about the example in the next video.